A single sleep cycle runs roughly 90 minutes, but your body does not care about the clock on your nightstand. If your alarm tears you out of the wrong minute inside that 90-minute window, specifically during deep, stage 3 slow-wave sleep, your cognitive performance drops below what it would be after 24 straight hours of no sleep at all. That finding comes from Dr. Cassie Hildich's research at NASA's Ames Research Center, published in 2019. And if you are over 60, this problem compounds in ways almost no one talks about. Most people believe the secret to good sleep is simple. Get 8 hours, set your alarm, wake up on time, be disciplined. That advice sounds logical. It is also dangerously incomplete. Here is what that advice misses. Your brain does not sleep in one continuous block. It cycles. Every night, your brain moves through a repeating loop, roughly 90 minutes long, passing through light sleep, deep sleep, and REM dream sleep before starting over. You go through 4 to 6 of these cycles per night, and the stage you are in at the exact second your alarm fires determines whether you wake up sharp or shattered. A 2006 study by Dr. Kenneth Wright at the University of Colorado Boulder demonstrated that participants woken from deep, slow-wave sleep performed worse on cognitive tests than people who had been awake for 26 consecutive hours. Think about that. A person who has not slept in over a day can outperform someone who slept 7 hours, simply because that sleeper was dragged awake during the wrong 3 minutes. This is not about how much sleep you get. It is about when, within your own internal cycle, you open your eyes. And once you understand how that cycle actually works, how it changes after age 50, how it fragments differently depending on your cortisol rhythm, and what it does to your brain's waste removal system, you will never think about your alarm clock the same way again. But the real question is not just what the cycle does. It is why waking up in the wrong minute creates damage that lasts for hours. To understand why the wrong wake-up minute wrecks your morning, you need to understand what your brain is physically doing inside each 90-minute cycle. The cycle has 4 stages. Stage N1 is the entry point. Your muscles relax. Your brain waves slow down. This stage lasts maybe 5 minutes. It is the shallow end of the pool. If someone whispers your name, you will probably hear it. Stage N2 comes next. This is where your brain begins generating sleep spindles, short bursts of electrical activity that ripple across your cortex at 12 to 16 cycles per second. Dr. Stuart Fogel at the University of Ottawa published research in 2017 showing that these spindles are directly involved in memory consolidation. They are not just noise. They are your brain physically transferring what you learned today into long-term storage. N2 makes up about 50% of your total sleep time. It is the workhorse stage. Then comes N3. Deep, slow-wave sleep. This is the one that matters most for this conversation. During N3, your brain produces massive, synchronized delta waves, slow, powerful oscillations running at just 0.5 to 4 cycles per second. Imagine the difference between ripples in a pond and a slow ocean swell. That is the difference between N2 spindles and N3 delta waves. During N3, something remarkable happens. Your brain's extracellular space, the gaps between your neurons, physically expands. Dr. Maiken Niedergaard's team at the University of Rochester discovered in 2013 that this expansion increases by 60% during deep sleep. That expansion allows cerebrospinal fluid to rush through your brain tissue like a pressure wash, flushing out metabolic waste, including amyloid-beta, the protein fragment linked to Alzheimer's disease. This waste clearance process is called the glymphatic system. Think of it like a dishwasher that only runs when the restaurant is closed. Your brain can either be active and working, or it can be cleaning itself. It cannot do both well at the same time. And the cleaning cycle runs hardest during N3. Now here is the problem. When you are pulled out of N3 by an alarm, your brain is mid-flush. The prefrontal cortex, the region responsible for decision-making, planning, and judgment, takes the longest to come back online. Dr. Pierre Bolkin's work at the Walter Reed Army Institute of Research showed that cerebral blood flow to the prefrontal region remains suppressed for up to 30 minutes after a deep sleep awakening. Your emotional brain wakes up first. Your rational brain lags behind. This is why you snap at your spouse at 6:15 a.m. and feel guilty by 7. This is why the car keys end up in the refrigerator. This is why you pour coffee into a glass instead of a mug and stare at it for 3 seconds before realizing what happened. The science has a name for this state: sleep inertia. And researchers at NASA found that its cognitive impairment can be worse than being legally drunk. But here is the part nobody mentions. After age 60, your N3 stages shrink dramatically, and that changes everything about when you should be waking up. A meta-analysis led by Dr. Maurice Ohayon at Stanford, published in 2004 and covering 3,577 healthy subjects, found that deep, slow-wave sleep decreases at a rate of roughly 2% per decade from young adulthood through age 60. By the time you are 70, your N3 stages may occupy as little as 5% of your total sleep. Compare that to a 25-year-old, where N3 makes up 20 to 25%. This does not mean you stop cycling. You still run through roughly 90-minute loops all night, but the composition of each cycle changes. Your earlier cycles, the first and second of the night, still contain the most deep sleep, but those N3 windows get shorter and shallower. Meanwhile, your lighter N2 stages expand, and your REM periods, which cluster toward the second half of the night, start fragmenting. What does this mean practically? It means that if you are over 60, the danger zone for a bad awakening shifts. You are less likely to be dragged out of deep N3 in the early morning because you may have already burned through most of your deep sleep by 1 or 2 a.m. But you are more likely to be woken during a fragile REM period around 4 or 5 a.m. And REM awakenings bring their own kind of trouble. If you have ever woken up at 3 or 4 a.m. with a racing mind, an unexplained feeling of dread, or a heart that seems to be beating too fast, this is what is happening inside your body. Between 2 and 4 a.m., your cortisol levels begin to rise. Cortisol is your stress hormone. It follows a strict 24-hour rhythm, bottoming out around midnight and climbing steadily through the early morning hours to peak about 30 to 60 minutes after you wake. At the same time, your melatonin, the hormone that keeps you asleep, is beginning its decline. These two curves cross each other somewhere around 3 to 4 a.m. That crossover point is a biological vulnerability window. The research is still evolving on this, but mounting evidence suggests that this hormonal shift makes your sleep lighter and your brain more reactive to internal signals. A full bladder, a creaky joint, a stressful thought that would not have registered at midnight. Dr. Jeannie Duffy at Harvard Medical School's Division of Sleep Medicine has shown that older adults experience a phase advance in these hormonal rhythms. Your melatonin starts dropping earlier. Your cortisol starts climbing sooner, which means the vulnerability window shifts forward, sometimes to 2 a.m. or even earlier. So now you have two forces working against you. Your deep sleep is shrinking, and your hormonal landscape is waking you up earlier. The result? You surface into consciousness during a light stage of sleep, sometimes between cycles, sometimes in the middle of REM, and your brain interprets this as morning. It is not morning. It is 3:17 a.m. But your body does not know that. If this is making sense and you want the part about how to actually work with your cycles instead of fighting them, subscribe now. That section is coming in a few minutes, and it changes the way you approach every single night. But none of this matters if you do not understand what your brain is doing to itself between midnight and 5 a.m., the hours most people think of as dead time. What almost nobody talks about is this. Your brain runs two completely different programs during the first half and the second half of the night, and each program has a different purpose. During the first half, roughly from when you fall asleep until about 1 or 2 a.m., depending on your bedtime, your brain prioritizes deep, slow-wave sleep. This is when the glymphatic system does its heaviest cleaning. Amyloid-Beta, tau protein fragments, and other metabolic debris are flushed from the interstitial spaces of your brain at a rate 80 to 90% higher than during waking hours. A 2020 study by Reddy and colleagues, published in Brain Sciences, confirmed that this clearance is driven by the large, slow neural oscillations unique to N3. The second half of the night, roughly 2 a.m. onward, belongs to REM sleep and memory processing. During REM, your brain replays the day. It strengthens neural pathways for skills you practiced. It integrates emotional experiences. It prunes connections that are no longer useful. Here is the critical fact. These two programs are not interchangeable. You cannot make up for lost deep sleep by sleeping longer in the morning, and you cannot replace lost REM by going to bed earlier. Your brain is wired to run Program 1 first and Program 2 second, in that order, every single night. The sequence is hardwired. So when someone tells you, just get your 8 hours, they are ignoring the architecture of those hours. Sleeping from 10 p.m. to 6 a.m. is not the same as sleeping from 2 a.m. to 10 a.m., even though both are 8 hours. The first schedule gives you strong N3 cleaning in the early cycles and full REM processing in the later ones. The second schedule cuts your deep sleep short because your circadian system was already pushing toward wakefulness by the time you fell asleep. 14 million Americans over 65 are living with some form of cognitive impairment. Researchers at the University of Rochester believe that impaired glymphatic clearance from fragmented sleep, reduced deep sleep, and chronic awakenings during the wrong cycle phase is one of the contributing factors. The cleaning crew shows up, but the restaurant never fully closes. Read that line again. Your brain's cleaning system works best when your neurons quiet down. Every time you surface from deep sleep too early, whether from an alarm, a bathroom trip, or a cortisol spike, you are interrupting the rinse cycle. And unlike a dishwasher, your brain does not just pick up where it left off. It resets. It starts the stage over. Some scientists dispute whether the reset is complete, but the pattern is consistent across multiple studies. Nathaniel Kleitman, the man often called the father of modern sleep research, proposed the basic rest activity cycle, or BRAC, back in the 1960s at the University of Chicago. He observed that the 90-minute rhythm does not stop when you wake up. It continues throughout the day. Periods of higher alertness alternate with periods of lower alertness, roughly every 90 minutes. Depending on who you ask, this means the time you wake up does not just affect your morning, it sets the oscillation pattern for your entire day. So the question becomes, if your body is running a 90-minute internal clock all night, and if waking up at the wrong minute inside that clock can ruin your morning and possibly your whole day, how do you figure out the right minute? Here is a practical system based on what the research supports. It is not complicated, but it requires paying attention to your own body for about 2 weeks. Step 1. Establish your natural sleep onset time. For the next 7 nights, go to bed when you feel genuinely sleepy, not when the clock says you should. Do not use your phone in bed. Do not watch television. Lie down, close your eyes, and notice what time you actually drift off. Most people over 60 find their natural onset is between 9:30 and 11 p.m. Write it down each morning. After 7 nights, you will have your average onset time within about a 20-minute window. Step 2. Count forward in 90-minute blocks. If your average sleep onset is 10:15 p.m., your first cycle ends around 11:45 p.m. Your second cycle ends around 1:15 a.m., third at 2:45 a.m., fourth at 4:15 a.m., fifth at 5:45 a.m. These cycle endpoints are your ideal wake windows, moments when you are naturally in the lightest phase of sleep, transitioning between cycles. Waking here produces the least sleep inertia. Step 3. Set your alarm for the cycle endpoint closest to your desired wake time. If you need to be up by 6 a.m., set the alarm for 5:45. Not 6, not 6:15. The difference between 5:45 and 6:15 might place you in 2 entirely different sleep stages. One that lets you spring up, another that makes you feel drugged. Step 4. Protect the first 3 hours of sleep above all else. This is where your deepest N3 stages live. Dr. Matthew Walker at the University of California, Berkeley, has emphasized repeatedly that the first half of the night is non-negotiable for brain health. If you must cut sleep short, it is better, biologically, not ideally, to cut from the end of the night rather than delay your bedtime. This preserves your deep sleep cleaning cycles. Step 5. If you wake up naturally before your alarm, get up. This is important. If your eyes open at 5:20 a.m. and you feel alert, your body has likely surfaced at the end of a cycle. Forcing yourself back to sleep means you will re-enter a new cycle, and when the alarm hits 30 minutes later, you will be deep in N1 or early N2, groggy, irritable, and slower than if you had simply gotten up. Dr. Ayus van Someren at the Netherlands Institute for Neuroscience has been studying circadian wake patterns in adults over 65 since 2009. His research supports the idea that older adults who respect their natural wake signals, rather than forcing a rigid schedule, experience fewer daytime cognitive dips and report better overall alertness. If even one of these steps was new to you, hit like. It tells the algorithm to show this to more people who need it. That is not a small thing. Someone in your age group is searching for this right now, and the algorithm will not show it to them unless people engage. Step 6. Use light as your first signal. Within 5 minutes of waking, expose your eyes to bright light. Natural sunlight is best. Even overcast daylight provides 10,000 lux, far more than indoor lighting. This signals your suprachiasmatic nucleus to suppress melatonin production and lock your cortisol curve into its proper daytime pattern. Dr. Sachin Panda at the Salk Institute has published extensively on this. Morning light exposure within the first hour of waking is one of the most powerful circadian reset tools available to you. It costs nothing. Here is what all of this adds up to. You have been told for decades that sleep is one thing, that it is a block, that you either got enough or you did not, that the number on the clock when you set your alarm is what matters. It is not one thing. It is a sequence, a precisely timed, biologically orchestrated series of brain states that each do something different: cleaning, storing, processing, repairing. And the minute you wake up determines whether those programs completed their work or got interrupted mid-sentence. After 60, your body does not stop running this program, but the program changes. Your deep sleep shrinks. Your hormones shift earlier. Your vulnerability windows move. And if you do not adjust your behavior to match those changes, you will wake up every morning feeling like you barely slept, even when you logged 7 or 8 hours. This is not about discipline. It is not about willpower. It is about biology. I want to hear from you. Drop a comment below. Do you wake up between 2 and 4 a.m.? How often? And did anything in this change how you understand why? I read these comments. The patterns people report are remarkably consistent and remarkably fixable. I'd bet most of you have experienced that groggy, disoriented, almost angry feeling of a bad alarm waking. Now you know what was happening inside your skull. Your prefrontal cortex was offline, your glymphatic system was mid-rinse, and your cortisol was spiking into a brain that was not ready to receive it. You were not lazy. You were not failing at sleep. You were waking at the wrong minute. Your body keeps perfect time. You just were not listening. Share this with someone who struggles with their mornings, with someone who thinks they are just bad at sleep. They are not. And if you have not subscribed yet, you should. What is coming next week involves the single most overlooked factor in sleep quality after 60. And I've been pulling research on it for 2 months. Your sleep is not broken. Your timing was.